Welcome students. Today we will solve second problem on kinematics of particles. So let us start today's lecture. So we are given one problem over here. Let us read the statement. The motion of a particle is defined by the relation. So we are given one relation over here which is in terms of x and t, where x and t are expressed in meters and seconds respectively. Determine the time, the position and the velocity when acceleration of the particle is zero. So we are given one equation in the question which is the equation of position of particle, and that is in terms of time. X is mentioned in meters and time is mentioned in seconds. And we are asked to find the time, the position and the velocity of the particle when acceleration will be zero. So that means first of all we need equation of the acceleration. So we are given this equation, that is equation of the position of the particle. So in order to get the equation of acceleration, first of all we have to take the derivative of this equation, and if we take the first derivative we'll get equation of velocity, and after that we will take the derivative of the equation of velocity for one time and we will get equation of acceleration, or we can say take the double derivative of this equation, then we will get equation of acceleration. So let us take the first derivative. So first derivative of this equation with respect to time will be 24t cube minus 6t square minus 24t plus 3. So that will be velocity. So velocity is equal to 24t cube minus 6t square minus 24t plus 3. In order to get the equation of acceleration, we have to take the derivative of this equation again. So that means acceleration will be equal to 72t square minus 12t minus 24. So now we got the equation of acceleration, which is in terms of t, of course. Now we have to find the time, the position and the velocity of the particle when acceleration is equal to 0. So for that what we'll do, we have to put a equal to 0 in this equation in order to get the first answer, that is time. So let us put a equal to 0 in this equation. So when we'll put a equal to 0 over here, then we will get a quadratic equation in terms of time. And in this equation we have value of a as 72, value of b is minus 12, value of c is minus 24, because quadratic equation is written like ax square plus bx plus c. So a is 72, b is minus 12 and c is minus 24. So now we will apply the formula for the quadratic equation, and that is equal to minus b plus minus b square minus 4ac. We have to take this under root of this part divided by 2a. So let us put these values in this formula and we will get value of time, and we will get two values. Of course we will consider the positive value of time because time cannot be negative. So we will get time equal to 0.667 seconds. So this is the first answer for this problem, that is time of the particle when acceleration is 0. Now we have to find the position of the particle when acceleration is equal to 0. So that means what we need to do, we have found that at this time the acceleration of the particle is 0, and now we have to find the position of the particle when acceleration is 0. That means we have to put this time or put this value in the equation of the position, because at this time acceleration is 0. So when we will put this time in the equation of position of the particle, then we will get position of the particle when acceleration is 0. So we have to put t equal to 0.667 in this equation, then we will get value of x, that is the position of the particle when acceleration is 0, and it is equal to 0.264 meters because we are given x in terms of meters in this equation. After that, we need to find velocity of the particle when acceleration is equal to 0. That means now we have to put this value, that is time equal to 0.667 seconds, in the second equation, and we will get the velocity of the particle when acceleration is 0. So that will be equal to minus 8.65 meter per second. So this was a very simple numerical. We were given one equation which was of the position of the particle, and we are asked to find time, position and velocity at when acceleration of the particle is 0. So I hope this numerical is clear to you. Thank you very much.